back for the second part here. We're going to try and do this one. So they're fractions, but it's not adding or subtracting them. So we aren't looking for a common denominator. We just want to make these two sides equal. So if you think about the strategies, there's no Pythagorean identity. Can't do that. There's no factoring. There's no common denominator. So you get a couple different options here. There's a way to do it in one step, but I want to show you another way first. So you could take this here and say, okay, here's this side. So remember, can't touch these. So don't multiply across by this or anything, or divide by it. So just don't touch the sides. So you could take this and you could multiply by some multiple of 1. So we've seen how these conjugates can get things to cancel out and maybe even give us some squareds. So this would give us cosine squared on the bottom, middle terms cancel, -1, which doesn't really help us. It gives us a negative sine squared, but I mean, that is something you can do with the strategy sometimes. We could do that because it's 1. We're not doing it to each side. We're just manipulating the one side. So that's not going to help us, even if we did try that in this case. Here's the one step. Don't even touch this left side. There's really nothing you could do. Come over here. You get secants, you got cosines on the other side. Write it that way. 1 over a cosine, 1 minus 1 over a cosine. Now, you can go in and say, I'm going to multiply every single term by a cosine. And I can do that because I'm doing the exact same thing to all these terms. You can't just randomly pick 2 of the 4 or 3 of the 4. You have to do it to everything. Those will cancel, and you're done. Cosine theta plus 1, cosine theta minus 1, and that's it. Okay? Be very careful how you write this. So you saw the way I wrote it up there with multiplying all 4 pieces by it. We've had instances in the past of people just going, oh, times cosine, and then giving me this answer. I understand what you're doing, but it's not mathematically correct because that just looks like you're multiplying one thing by it. You can put a big bracket here and do that. That implies that you're bringing this into all the places. That's fine. But, you know, pay attention to those math things and take care of them. Last identity is this one. Secant squared minus 1 over secant squared equals a sine squared. Sine squared's a pretty straightforward thing, so just leave that alone. Don't touch it. Come over here. Secant squared minus 1. You could look for some Pythagorean identities if it actually is something. That's a possibility. I'm going to try this. I'm going to say a secant squared is the same thing as 1 minus a cosine squared, or 1 over a cosine squared minus 1, and then this is 1 over a cosine squared. So fractions within fractions, make sure you write them, upwards like that. Now I'm going to clear out the fractions by simply just multiplying everything by cosine squared. So I'm going to multiply this one by a cosine squared. I'm going to multiply this one by a cosine squared, and this one. When I do that, this will cancel, give me a 1. This will give me cosine squared. Those will cancel, give me a 1 on the bottom. I'm not even going to rewrite that. And you're back to kind of the same thing again. Sine squared equals sine squared. So you are done. Okay, you could do a Pythagorean identity with that one and replace it and see what happens, and you'd probably get the same thing. There's short ways to do them all, there's long ways to do them all, and sometimes you may do something for 10 minutes and realize you got to scrap. So the best way is just practice, 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 and see multiple types of these identities. So we will keep working on those in class the next few days, and see you then.